This question is from GATE 2014 Mechanical Engineering paper set 4, question number 55. A butt weld joint is developed on steel plates having yield and ultimate tensile strength of 500 megapascal and 700 megapascal respectively. The thickness of plates is 8 mm and width is 20 mm. Improper selection of welding parameters caused an undercut of 3 mm depth along the weld. The maximum transverse tensile load in kilonewton carrying capacity of the developed weld joint is dash. Let's write the given things. So it is given that yield strength of steel is 500 megapascal and its ultimate strength is 700 megapascal. We can write sigma y is 500 megapascal and sigma ut, ultimate tensile strength, is 700 megapascal. We have to design a butt weld joint. It should be known that butt weld joint is to be designed for ultimate strength. It is not designed for yield strength because the criteria of strength is taken into account, not of serviceability. Another thing that is given is size of weld. Thickness of plates is given 8 mm and width is 20 mm. So along the width, along the complete weld, the weld will have to be carried out. So we can write B is equal to 20 mm. Thickness of the weld should also be equal to the thickness of the plate so that it successfully joins the plates together. So we can write thickness of weld itself will also be 8 mm. Width of weld is 20 mm. There is an undercut of 3 mm. So we'll write that undercut as D being 3 mm. Let's see how the undercut will be incorporated in the size of the weld and then how the carrying capacity of weld joint will be calculated. Let's see. So from the sizes given, we can calculate the area of weld. Area of weld, generally it is width by thickness simply. But here there is an undercut. So the undercut has to be subtracted from thickness because it is thickness wise. So we'll have area of weld will be TW minus D into BW. Let's substitute 8 minus 3 into 20, which is 8 minus 3 is 5 into 20, 100 millimeters square. This is the area of weld. So transverse tensile load carrying capacity of the weld, simply let that be capital TW, will be equal to area of weld into the ultimate strength of its material. So sigma ut. Let's tally the units also. Area is in millimeters square. Sigma ut is in megapascal. Megapascal is equivalent to Newton per millimeter square. So we can directly adopt this value 700. There is no factor of safety given and that is why we are not incorporating any factor of safety from our side. So whatever the given values are, we'll substitute in the problem and calculate. Area is 100, sigma ut is 700. So it simply has to be 70000 Newton. We have to convert it in kilonewton in order to mark in the answer. We get dividing by 1000. The carrying capacity as 70 kilonewton. Let's go back and fill in the answer. So we have maximum transverse tensile load carrying capacity of the developed weld joint is 70 kilonewton. To learn more about welded joints, you can refer to the NPTEL video lecture 24 Design of Welded Joints 2 from the course lecture series on Design of Machine Elements 1 by Professor B. Mehti. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.